and welcome my wonderful honor students to day 4 information you're going to need for class. We're going to review a little bit of velocity and then talk about acceleration as our starting point today. I'm excited to teach you. So a quick review. Velocity is the displacement in a period of time. We knew this from class. We also know it's displacement over time in meters over seconds. And just like displacement, we said it has two parts in class. It's got a direction. We said in class, positive, negative, north, south, east, west. All these things are possible directions. And then it has an amount. A big vocabulary word coming. That word amount stinks. Let's call the amount, or how much, the magnitude. So this word magnitude is just pretty much the number part of velocity. So let's start with a scenario to understand velocity. You are going to now take your pencil in your hand because you have your pencil out because you're writing down these notes. If not, you're going to pause, get your pencil and your notebook, come back, review from the beginning, and when you hear this part again, you'll be like, I got you, Jock. And I know you do. Toss the pencil up in the air and make sure it comes right back down your hand. And your hand should not have moved. If you had to go down and pick up your pencil because you dropped it, do it again. In this case, since the pencil started and ended at the same place, your hand, at the same height, the displacement was 0, because the start and end points are the same. And so therefore, the overall velocity is also going to be 0. No displacement over the time. So what we just did is we found the overall velocity. We're going to call that the average velocity. Again, displacement over time. Here's where it gets a little bit weird. You know that even though the pencil ended back up in your hand, even though the overall velocity was 0, it was still moving pretty much the entire time in the throw. So we got to go a little more in depth here. So the velocity at a single moment, whether it's 1 second in, at the beginning, or at the end, plays a big role in physics. So for the starting velocity at a period of time, we're going to call that starting velocity VI. And for the final or ending velocity, we're going to call it VF. Now, I don't just mean overall, like the moment it left your hand and the moment it came back in your hand. Initial and final can be any points along that throw. It just depends what you're looking at. So I created a little demonstration to help you out here. Here's a number line. On the bottom, you could see the time in seconds. At the top, you can see the velocities, meters per second. So when you start the clock here, you're already going 20 meters per second. A second later, you're going 25. Another second later, you're going 30. 6 seconds after you start timing, you're going 50 meters per second. See that blue segment right there? Just for that little segment of time, we're going to talk about it. We're going to say it starts at 20 meters per second, so that's VI for this. It ends at 35 seconds, that's VF for this segment. And this segment is from 0 to 3, so 3 seconds long. Cool. Now get the red one. The red one does not start at 0, so its VI is not 20. It's like it got shifted down. So if you could somehow cover up the first 2 seconds, this VI for this red segment starts at 30. And the end velocity for this red segment is at 50. And how many seconds? From 2 to 6 is 4 seconds. So here we are. Notice how, depending on when you look at the times, VI can change. That's be a big deal in physics. We're not always going to look at the beginning of the clock to the end of the clock. We're going to look at small parts in between. So look at the green one right here. From 25 to 35 in 2 seconds. VI is 25, VF is 35. So in summary for this little section, I wanted you to understand that just because it starts off at 20 at the beginning of some time, VI is not the same as that starting number. It depends on the segment you're looking at of its motion. And now for the last part, acceleration. Huge idea in physics. Huge. Those 3 laws you learned in middle school, for every action, there's equal opposite reaction, blah, blah, blah. Those deal with acceleration here. So I'm going to give you the basic framework in the next like 2 or 3 minutes, and then we're going to explore it in depth in class. Here's the idea of acceleration. We kind of talked about it. It's how quickly you change your speed. I put speed in quotes because it's not exactly true. It's just pretty much how quickly you speed up or slow down. This symbol is an A in meters per second squared. You had this written in your table from about, I think, day 1 or day 2. And here's the big deal. Acceleration is your velocity change over your time. Change in velocity over time. And just like velocity and displacement, it has a magnitude, an amount, and direction. As an example, gravity is downward. We're going to say it has a value of around negative 9.8. 9.8, the absolute value, is your amount, magnitude, and the negative, or down, is your direction. Lastly, here's how I want you to think about it. Let's say a person has an acceleration of 2 meters per second squared. That means that every second they gain a velocity of positive 2. So in 1 second, how much velocity they gained? Well, their acceleration is 2 meters per second squared. So every second they gain 2 meters per second. So in 1 second they gain 2 meters per second. In 2 seconds they gain 2 meters per second plus 2 meters per second. They're now going 4 meters per second. Have they gotten faster? Of course. They're gaining this forward speed. Now at this point, you are done with this basic stuff. You should have some decent note taken, and I look forward to teaching you. However, we're going to come back to this in class, and we're going to see how it's a lot more complex. But that, my friends, is for another day. Take care and have a wonderful day.